In this example, we are told that the gravitational field at the surface of the Earth is 10 newtons per kilogram. We are asked to find the gravitational field at a distance that is twice RE, RE being the radius of the Earth. Remember the expression for the gravitational field. It is G, capital G, times the mass of the planet that's responsible for that field over the distance from the center of that planet squared. Remember, capital G, I'm going to write it aside here, is the universal gravitational constant, which is 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared. That's the universal gravitational constant that we have here. Mass would be the mass of the planet that we are finding G, that's responsible for G, and R is the distance from the center of that planet. So this 10 newtons per kilogram is at the surface of the Earth. So that one corresponds to the mass of the Earth over RE squared. This is what's equal to 10 newtons per kilogram. The question is to find it at 2 point RE. G at that new position is still due to the Earth, so it's mass of the Earth, but instead of RE for the distance away from the center, it's going to be twice RE squared, which is G ME over the twice here. I'm going to take it out, so it becomes 2 squared, which is 4 RE squared, which is 1/4 of G ME over RE squared. Note that this is the same as this, so it is 1/4 of this, which is 10 newtons per kilogram, which gives us our answer of 2.5 newtons per kilogram. The second question is asking us about the gravitational force acting on that person at that same position, 2.0 away from the center of the Earth, 2.0 RE from the center of the Earth. And we are told that the gravitational force, or the weight of that person when at the surface of the Earth, is 500 newtons. So to solve that, we need to remember that the gravitational force is related to the gravitational field through this expression, mg, where m would be the mass of the person. So at the surface of the Earth, in this case, we have Fg is equal to mg at the surface of the Earth, which is m times 10 newton per kilogram. And in this case, we were told that it is 500 newtons. And we are asked to find Fg at this new position at 2RE. This is just at, not as a function of. So Fg at that position is going to be the same expression as this. M, but G at the 2RE, which is going to be M. And remember, we just found that G is 2.5 newtons per kilogram. So M times 2.5 newtons per kilogram. So all what we need is to know the mass. The mass, we can know it from here. That's M times 10 newtons per kilogram. That's the information from the surface of the Earth, is 500 newtons. So that leads us to the mass is 500 over 10. That gives us 500 newtons over 10 newtons per kilogram. Newtons cancel, the kilograms goes on top, and we are 50 kilograms. We replace that in the equation, so we have our Fg is 50 kilograms times 2.5 newtons per kilogram, which is equal to 125 newtons. That's our answer.